This tutorial will cover calculating the pH of strong acids. Before we get into the calculations, we should probably review the difference between a strong acid and a weak acid. Strong acids are 100% ionized. That means that every molecule in the solution is split up into ions. Whatever you put in there will be completely ionized. This means if you have 1 molar acid, when it breaks up it will give you 1 molar hydrogen ions and 1 molar of its conjugate base. We can compare this with a weak acid, which is less than 100% ionized. When you dissolve the weak acid in solution, you will find that you get just a few of the molecules breaking up to give you ions, but the vast majority of them will stay together. This means that if you have 1 molar weak acid, you have much less than 1 molar hydrogen ions and much less than 1 molar of the conjugate base. So in this tutorial, we're going to focus on strong acids, which are 100% ionized. For our first example, we'll calculate the pH of 0.073 molar nitric acid. The very first thing you need to do is to recognize that this is a strong acid. It's on our list of strong acids right here. What we really have in solution is 0.073 molar hydrogen ion and 0.073 molar nitrate ion, because this is a strong acid which is 100% ionized. Once we have the hydrogen ion concentration, calculating the pH is simply a matter of taking the negative log of the hydrogen ion concentration. This will give us a pH of 1.14, keeping in mind that the 2 sig figs in the hydrogen ion concentration translate to 2 decimal places in the pH. It's always good to get in the habit of asking yourself, does this answer make sense? And right now we know we have a strong acid and the pH is very low, which is an acidic pH, so the answer does make sense. If you are asked to calculate the POH or the hydroxide ion concentration, you can easily do that using the relationships between pH, POH, H+, and OH-. Let's try another problem. In this problem, we are given the pH of a solution and asked to calculate the concentration of the acid. The very first thing you should do is to look at what the solution is. In this case, it's HBr, which is hydrobromic acid, and it is on our strong acid list right there. Once we identify it as a strong acid, we will know exactly what to do with it. We know that we can go directly from the pH to the hydrogen ion concentration by taking 10 to the negative pH. With this, please note that since the pH is expressed at 2 decimal places, I have put 2 sig figs in my hydrogen ion concentration. Since this is a strong acid, we know that the hydrogen ion concentration is equal to the original hydrobromic acid concentration. So therefore, we can conclude that the original hydrobromic acid concentration is 6.3 times 10 to the negative 4th molar.